Yesterday we defined kinematics, the branch of physics that we're starting off with. Kinematics as the study of motion without regard to what causes that motion. In other words, we're studying the movement of things, but not paying any attention to, what's the F word that I want to hear from you right now? Force. Somebody said it. Sorry. Force, yeah. We're not paying any attention to the force that causes it, the push or the pull that causes the motion. So we're studying velocity, we're going to study acceleration and so on, but not the forces that cause that velocity or the forces that cause that acceleration. Now, we defined a couple of terms yesterday. One was a vector and one was a scalar. And then we distinguished between three other terms, distance, position, and displacement, whether they were vectors or scalars. You guys remember right now what the difference between a vector and a scalar was? Your hint is on the board, right? What's the difference between a vector and a scalar? Good. You see the magnitude down here, 400 grams is the size of that box, right? The magnitude of the box. Okay, that would be applicable to both a vector and a scalar because both of them have magnitude. But vector, if you were to look at the side of this box, has direction as well. Vector has both magnitude and direction, whereas a scalar has just magnitude. Now, we looked at three terms, distance, position, displacement. I want you to tell me which of these three terms right now are scalars. Distance, position, displacement. Which one or ones are scalars? We'll give you a chance to actually answer this time. Distance, good. Distance is a scalar. Does that mean the rest of them are vectors? Yeah. So direction doesn't matter for distance. The example that I used yesterday, we said that I drove 75 kilometers to Staveley for my son's hockey game on Sunday, and then I drove 75 kilometers back. The odometer of my car read 150 kilometers when I got back. It didn't care that I went south and then I went north. It just cared that I drove 150 kilometers. It measured my distance traveled. Position, on the other hand, is a vector. Position is defined as where something is. Where am I right now? I'm 2 meters north of the wall. We need a direction associated with that, right? Where is Staveley? It's 75 kilometers south of Okotoks. If my son's hockey coach said, oh, make sure you're in Staveley by 10 o'clock on Sunday morning, and I said, well, where's Staveley? And he said 75 kilometers away, that wouldn't do me any good. I need him to tell me that it's 75 kilometers south of Okotoks. I need a direction when I measure position, where something is. So position is a vector. Displacement we define as the change in position. So that's one position minus another position. It's going to be a vector as well. Because of course, if you've got a position, which is a vector, then the change in a vector has got to be a vector as well. The units for all three of them are going to be meters, although you can sometimes use kilometers or even millimeters or centimeters. But the standard unit is meters. If in doubt, go with meters because meters always works. The other units sometimes work. Meters always works. And finally, the symbol. You guys remember the symbol for distance? Yep. Yeah. What is the triangle? What's that symbol? Delta. And what does delta mean? Anybody? Change. Delta means change. To change in D, right? It's a distance covered, change in kind of where you are without direction. Position is going to be, remember that one? Remember that symbol? Yeah. Yeah, it's going to be D with a little half arrow over it. What does that half arrow mean? Good. Means it's a vector. Anytime you see D with a half arrow over it, you know it's a vector quantity. If you get a quiz, and you will get a quiz in a couple of days here, that asks you which of the following are vectors or scalars, and you forget, oh my goodness, I forget, is it a vector or is it a scalar? Check your data sheet. Look at your data sheet right now. There's a whole bunch of equations, many of which you've never seen before and you won't see for some time. But notice that some variables have a little half arrow over it, some don't. That's your little cheat sheet. You get your equation sheet for your quizzes and tests. So if you forget what's a vector and a scalar, check your data sheet. Look for the little half arrow. If it has the arrow, it's a vector. If it doesn't, it's going to be a scalar. What about displacement? we defined it as a change in position, so it's going to be good. Delta D with the arrow over it. Arrow meaning it's a vector, delta meaning that it's the change in position. Now, that's where we left off yesterday. Today, I want to expand upon what we did with displacement just a little bit. Displacement can be found in a couple of different ways depending upon the context of the question, depending upon what we're given in the question. Displacement, or delta D, can be found by adding displacements together. So in other words, if you've got 2 or 3 or 4 different displacements given to you and you want to find the total displacement, add them up. In other words, I walk 10 kilometers, that's a long walk actually, let's go 10 meters. If I walk 10 meters to the east, and then I walk 5 meters to the east, and then I walk 10 more meters to the east, then my total displacement would be the sum of those displacements. I've moved 10 meters, then 5 meters, and then 10 more meters. 3 different displacements, add them up to get the total displacement. Does that make sense? Versus, if I'm given 2 different positions, I subtract them. So for example, right now I'm 2 meters north of the wall. Now I'm 6 meters north of the wall. I don't add those together to get displacement. I subtract them. Remember the first example I gave you, we were given 3 different displacements. We added them together to get the total displacement. This time we were given 2 different positions, where I am or where I was. I subtract them. So if you've got displacements and you want to find total displacement, add them up. If you've got positions and you want to find total displacement, then subtract them. You got that? Make sense? Displacements, add to get displacement. Position, subtract to get displacement. Got a couple examples for you. And unfortunately, these don't appear in your textbook. You're going to have to copy these ones out. Sorry. So the question says, a student is walking from 7-Eleven to the dog stadium at the bottom of the hill. 7-Eleven is a kilometer south of HTA, and the dog stadium is, I should say, 2.5 kilometers south of HTA. Calculate the displacement of the student as she walks from 7-Eleven to the dog stadium. All right, clearly the 2 numbers that I have given to me here that are important are the 1 kilometer south of HTA and the dog stadium that's 2.5 kilometers south of HTA. Here's what I want to do. I want to first of all define a direction as positive or negative. Usually north is positive for us. Usually north is positive and south would be negative, okay? It doesn't really matter though, because both of these are to the south, it might make sense to define south as positive. Do whatever you want, but because everything is to the south, we'll make south positive. We probably should make south positive here. If something was north and something was south, we'd almost always make the north positive and the south negative. All right. What do we have given to us here? This 1 kilometer south of HTA and the 2.5 kilometers south of HTA. Are those displacements or are those positions? Listen carefully, I'll rephrase the question. Are those how far we've gone or are those where we are? Are they displacements or are they positions? They're positions. They're where we are. They're where we are, right? I am 1 kilometer south, or 7-Eleven is 1 kilometer south of HTA. It doesn't say that I walked 1 kilometer from HTA to 7-Eleven. I had to get there somehow, but maybe I didn't start at HTA, right? We're saying this is how far 7-Eleven is away from HTA, but we never said that I started at HTA. This is where 7-Eleven is. 7-Eleven isn't going anywhere. 7-Eleven is in this spot, 1 kilometer south of HTA. So we're going to say the original position, or DI, the initial position, not the displacement, the initial position is 1.0 kilometers. Had I defined north as positive, what would be my initial position here? We would have made it negative 1 kilometer, right? Which would have been fine. But it's probably easier to deal with positives than it is to deal with negatives. 2.5 kilometers south of HTA, that's the dog stadium. That's my final position. I went from 7-Eleven to the dog stadium. I didn't walk 2.5 kilometers from 7-Eleven to the dog stadium. That's where the dog stadium is. 2.5 kilometers south of HTA. How do you find the displacement? Well, if you've got displacements and you want to find total displacement, if you've got displacements and you want to find displacement, if you've got displacements, you add. If you've got positions, like we have here, then we subtract, right? So this is going to be df minus di. So what's my displacement? You guys probably could have figured this out without writing anything down, right? But it's a good habit to start writing it down, because when the questions get harder, you're going to have to, right? How far did I walk? 1.5 kilometers, of course. If one of them is a kilometer away and one of them is 2.5 kilometers away, and I went from one to the other, I walked 1.5 kilometers. Hey, I got a positive value. I got a positive answer there. What does that mean? Yeah, Andres? It was south, because I defined south as positive. Had I defined north as positive, then it would have went negative 2.5 minus negative 1, right? It's 2.5 to the south, 1.0 to the south, and that would have given me negative 1.5 kilometers, which would have meant, if I define north as positive, negative would have meant south. So it doesn't really matter which one you define as north and south, but I think you'll agree that a little bit easier if they're both south to make south positive. Is that okay? When you've got two positions, then you need to subtract to get displacement. If you've got two displacements, which we don't here, then we've got to add them. Okay, let's try one more. This one says a student walks 1.5 kilometers south from 7-Eleven to the dog stadium and then turns around and walks 2.5 kilometers north to HTA. Calculate the distance traveled by the student and the displacement of the student. This question sounds a lot like the last question, but there's a difference. We're told this time that the student walks from 7-Eleven to the dog stadium this distance. We're not told where the dog stadium is or where 7-Eleven is. We're told how far the student walks. What are we given this time versus last time? We're given displacements, right? This is how far he goes. This is how far he goes after that, not where he is or where she is now and then. Let's define something as positive. Since we got a north and a south here, probably let's go north as positive this time. That means that delta D1, the first, not position, the first displacement is negative 1.5 kilometers. I walked 1.5 kilometers from 7-Eleven to the dog stadium. And then I turned around and I walked another displacement, which was positive 2.5 kilometers, positive because it's to the north. This one's a bit different. We want to find the distance and the displacement this time. Let's worry about the displacement first, okay? What do we got to do? Add or subtract? Ethan? We're going to add them this time, right? If we're given positions, we subtract. If we're given displacements, we add. So let's say displacement is going to be delta D1 plus delta D2 it's going to be negative 1.5 plus 2.5. That's kind of like subtracting, right? Because one's a negative. It's kind of like it. Yeah, it is kind of like it, but there's not always going to be a negative value in there. So we're still adding. We just happen to be adding a negative value this time. Add those up. What do we end up getting? Is that 1 kilometer? What does that mean? Yep. My change in position is 1 kilometer. In other words, I ended up 1 kilometer north of where I started. Intuitively, that might make sense, right? We start at 7-Eleven, we go 1.5 kilometers south, and then we go 2.5 kilometers north. We end up a kilometer north of where we started. What's my distance traveled? Distance is the scalar, right? You want to find distance? So let's add up distances instead of displacements. What's the first distance? Ethan, what's the first distance? Good. Why is it not 1.5, not negative 1.5? Right. Distance is a scalar, no direction associated with it. So let's make it positive. Forget about positives and negatives and north and south and whatever. It's all the same. 1.5 plus 2.5 gives me 4. Okay, if I'm wearing my pedometer or if I'm wearing my GPS running watch and I go 1.5 kilometers from 7-Eleven to the dog stadium and then 2.5 kilometers back to HTA, what does my little watch say? It says I've went 4 kilometers. It's measuring distance, right? If I want my displacement, it's only 1 because I'm only 1 kilometer north of where I started. But if I want distance traveled, then it's 4 kilometers. Good. There's a worksheet going around right now that does essentially what we just did on those 2 questions. Distance, position, displacement, distinguishing between the 3, finding the 3. Remember a couple of things. First of all, remember that if you've got, especially if you've got 2 different directions, north and south, right and left, east and west, something's got to be positive and something's got to be negative. Secondly, remember, identify whether you've got displacements or you've got positions. If you've got displacements, you're going to add them together to get displacement. And if you've got positions, you're going to subtract them. So once you have a copy of this worksheet, sit down and see what you can do with it, okay? We'll give you probably about 15 minutes here to see what you can do with these 9 questions that appear on that worksheet. Please, as I'm walking around, stop me. Ask me questions. Okay, if you're struggling with something, get some clarification on it. All right, let's take a look at one of these questions just for a little bit more help if you're in the middle of working on these. Question number 6 we want to do right now. It says a woman begins driving her car 200 kilometers north of Calgary. Sometime later, the woman in her car are 100 kilometers south of Calgary. What's the distance traveled by the woman in her car, and what's the displacement of the woman in her car? What are we given here? Are we given the position times 2 of the woman in her car, or are we given the displacement times 2 of the woman in her car? Is this where the woman in her car is, or is this how far the woman in her car have traveled? To where they are. This is where she begins. She begins at this spot, 200 kilometers north of Calgary, and she ends 100 kilometers south of Calgary. I'll give you a little hint here. Position always needs a frame of reference. Position always needs a reference point. Okay, when my son played hockey in Staveley on Sunday, if I ask my coach, my son's coach, where's Staveley? Okay, he's going to say it's 75 kilometers south of Okotoks. Okay, I need to know that it's south. That's important because I don't want to drive east or west or north. But I also need to know that it's 75 kilometers south of Okotoks. 75 kilometers south of what? If he just says it's 75 kilometers south, that doesn't help me. 75 kilometers south of Okotoks. So when you're talking about a position, where something is, you need to say what it's from. Like, 75 kilometers from what? Right? You need a reference point. If you see that reference point, you've got position. If you don't see a reference point, you've got displacement. This is my initial position. DI is 200 kilometers. Let's make north positive, by the way. My final position would be negative 100 because it's 100 kilometers south of Calgary, right? My distance, my displacement, let's do my displacement first. DF is negative 100. DI is 200. It's subtract positive 200. That gives me negative 300. What's my displacement? Neg 300 or 300 to the south, right? That makes sense? What's my distance traveled? What's the distance in that one? 300 kilometers. How come it's the same number? How come distance and displacement are the same numbers there?
Because she didn't go up and then down.
Right. Didn't change directions. I got a north and a south in here, but she didn't change directions. She went south the whole time, right? Remember yesterday, if I walk this way and then I turn around and walk this way, the two numbers are different. But if I keep going the same way, distance to displacement will be the same number, just that displacement has a direction, distance doesn't. Okay, is that okay? So I think that's going to help you with number 4 as well. 4 is a little bit easier because we're not dealing with the negative. And number 4, everything's to the north. Okay, I'll give you another couple minutes to work on these questions on the worksheet, and then we're going to go just a little bit further with stuff, okay? All right, I'm going to assign a few more questions in addition to what we just did on the worksheet as well. You got some check and reflect questions on page 10. We're going to assign number 1 to 7. So you got those, I think it's 9 questions on the worksheet, 7 questions here. You've had quite a bit of time already. Some people are done the worksheet, some people aren't. And you will have more time before the end of class to go back and work on the worksheet and these 7 questions. So it's not like you're going to have 17 questions for homework. But what I want to do right now is move on and define 3 more terms, talk about those as vectors or scalars, and then what we do with those terms. Time, speed, and velocity. You know what, I said we're going to define 3 more terms. We're not. We're going to define 2 more terms. We're not going to define time. The reason we're not going to define time is because I have never seen a good definition for time. Time is one of those things that everybody knows what it is. Right? I know what it is, you know what it is, but try defining it. Try giving me a good definition for time. I've never been able to come up with a good one myself. I've never seen a good definition for time myself, including in textbooks, including in dictionaries. But we all know what it is, so we're going to leave that one. The symbol for time would either be T or delta T, depending upon context. Anybody want to take a stab at when it might be T, when it might be delta T? Brennan? Okay, delta T would be a time interval, a change in time. T, if I was looking at my watch, look, it's 2:59 right now when I look at my watch. T is 2:59. If I look at my watch a little bit later and it's 3:03, then that would also be a T. Delta T would be 4 minutes. Make sense? T is at a moment, delta T is an interval. 9 times out of 10, we're dealing with delta T. So this is the one that we pay closest attention to. Delta T, the time interval. The units for time, hours, minutes, days, years. The standard unit is the second. If in doubt, go with seconds. Time is going to be how do you know it's going to be a scalar? Because what? Well, you don't have direction. I've never heard somebody say, oh, it's 4 meters to the east. Sorry, 4 seconds to the east. Oh, yeah, that one. Yeah. Biology class today was was 80 minutes to the south. We don't talk about a direction with time, right? What's the other way that you can determine the time's a scalar? Look at it, quick. Yeah, I can't go backwards. Yeah, I can't go backwards. Look at this. There's no little arrow over it. I gave you the symbol, there's no little arrow over it. Good, so time's a scalar. Speed, we're going to define that one, although we pretty much know what that means as well. How fast something moves. Symbol, might want to call it an S, but we're not going to do that. We're going to call it a V. Units would be, well, kilometers per hour. Standard units are meters per second. If in doubt, go with meters per second. Vector or scalar? Yep. How do you know? Yes, you can. Yes, you can go backwards. What does the speedometer in your car measure? Does it measure distance? Does it measure speed? Does it measure what does the speedometer in your car measure? No, forget about that. I don't want a calculation there. I just want, like, when I look at my speedometer on my car and it says 108 kilometers per hour, what is that? Okay, you guys are going way too deep here. It's speed, right? It's telling me how fast I'm going. It's telling me my speed, right? Right? It's not telling me which direction I'm going, right? Speed is a scalar. Speed's a scalar. Another way that we can determine that it's a scalar, look, no arrow on top of the V, right? Now you guys are just too smart. You guys are getting ahead of yourselves a little bit. You can find speed by using the equation distance over time. Speed is distance over time. Now it's starting to come together a little bit. We just spent a significant amount of time in this class doing a couple of example problems and 9 questions on a worksheet that asks you to find distance. If you want to find speed, get distance and then divide it by time. Do what we did for the first 3 quarters of class and then divide it by time. Velocity, the definition of this one's a little bit trickier. It's the rate of change of position. The symbol for velocity is V with the arrow over it. The units would be meters per second, standard units, that is, meters per second, and it's going to be a, somebody said it, it's going to be a vector. We know that because it's the rate of change of position, which is a vector, and we know that because there's a little half arrow over top of the V. You want to find velocity? It's displacement over time. It's not distance over time, it's displacement over time. So how do you get that? Well, do what we did. For 9 questions on the worksheet, get displacement, and then divide it by time. So what we did yesterday, and for the first part of today, was leading us into this. How do you get distance? How do you get displacement? We know how to do that now. So now, let's take what we learned and divide it by time to get speed and velocity. Got another one that you got to copy, sorry. It says Regina is 600 kilometers west of Winnipeg. Calgary is 1,350 kilometers west of Winnipeg. It takes a car and its driver 8 hours to get from Regina to Calgary. It's the car's average speed and velocity. What do we got here? It says Regina is 600 kilometers west of Winnipeg. Is that a position of Regina or is that a displacement? That's a position. That's where Regina is. Okay, the next one, Calgary is 1,350 kilometers west of Winnipeg. Is that a position or a displacement? That's a position. Those are two places. Those are two positions, where Regina is, where Calgary is. When I drive from Regina to Calgary, my initial position will be 600 kilometers. Let's define west as positive, right? Does that make sense? Usually we make east positive, but since everything is west here, let's go west positive. You want to make it the other way around? That's okay. My initial position is 600 kilometers to the west. My final position is 1,350 kilometers to the west. The time, what time would I use there? Would it be T or delta T? Delta, it's the time interval, right? It's not what time it is on my watch. It's how much time has gone by. All right. I want to find speed. I want to find velocity. Let's do velocity first. Sometimes I find the vector one easier. What's my displacement? Do I add or subtract? Remember, I got positions. Add or subtract? Subtract, good. So it's going to be df minus di over delta t. It's going to be 1350 minus 600 over 8 hours. That's going to be, what, 750 over 8? I think that's 93, isn't it? 93.75? When we get 94 then, 94 kilometers per hour. And since it's a vector, we have to have direction, but we kind of already have, right? Positive is west. 94 kilometers per hour west. We don't really need to write that in because we've done that here. Doesn't hurt though. What about speed? It's distance over time. What's the distance traveled here? Yeah, 750 kilometers, right? Divided by, what do we got, 8 hours? What does it give me, 94 kilometers per hour? Hey, how come the speed and the velocity are the same value here? Ethan answered this question for me earlier on a different question. How come the speed and velocity are the same number? Because I haven't changed direction, right? I went west the whole time. If I went west and then I changed and went east, then speed and velocity would be different numbers. Is that okay? Here's our last example of the day. This one says a hiker walks 300 meters east, then 1,200 meters west. If it takes a hiker 1,800 seconds, what's the hiker's average speed and velocity? So what do we have given to us here? The hiker walks 300 east, then 1,200 west. Are those positions or are those displacements? Are those where we are or how far we've gone? Those are displacements. It's how far we've gone, right? Let's define east as positive. Let's say my first displacement is 300 meters. My second displacement is negative 1,200 meters. My time interval, delta t, is 1,800 seconds. I want to find speed, and I want to find velocity. Let's go velocity first again. Doesn't really matter, but it's displacement over time. How do you get displacement from displacement? Add 300 plus negative 1,200. Now be careful, because the temptation is to say, oh, it's the same thing as subtract, right? Well, it is, kind of. But it's not always. It just is in this case because one of them is a negative, right? 300 plus negative 1,200 divided by 1,800 seconds. It gives us negative 900 over 1,800, which is negative 0.50 meters per second. What does a negative mean? West. Yeah, it's west, right? You could say negative 0.5, or you could turn around and say positive 0.50 meters per second to the west. Either way. Either answer is good. What's the average speed? Distance over time. What's the distance traveled? 1,500, 300 plus 1,200. Divide it by a time of 1,800 seconds. That gives me, I think it's 0.83, wasn't it? 0.83 meters per second, positive. Wait a second. How come it's a different answer than we got for velocity? Brennan? Yeah. Yeah, but you know what? That was the case over here as well, right? Okay, good. That's what I'm looking for. We changed directions. In this question, we kept the same direction. We're going west the whole time. In this question, we're going east and we're going west. When we keep the same direction, speed, velocity, the same thing. When we switch directions, speed and velocity are different, right? Just like distance and displacement.